The automotive industry just got a wake-up call, and it came from the sky. Elon Musk's latest creation isn't just another electric car or another self-driving feature. It's a completely reimagined vehicle that breaks every rule in the transportation playbook. And when the first prototype was revealed to the world in 2026, the entire industry went silent. This is the story of how one man's vision is reshaping the future of mobility in ways we never thought possible. Rush hours. It's all designed for vehicles that are locked to the ground. We've optimized for speed on roads, but we've never solved the core problem. There are only so many roads, and they're always full. Every major city in the world faces the same crisis. Millions of people spending hours every day stuck in traffic, wasting fuel, wasting time, wasting their lives on congested highways and city streets. Elon Musk saw this problem differently than everyone else. While other companies were trying to make cars go faster or smarter on existing roads, Musk was asking a fundamental question. Why do cars have to stay on the ground at all? This simple question led to one of the most ambitious projects ever attempted in the history of transportation. The project was called SkyCab, and it represented a complete reimagining of what a vehicle could be. When Tesla announced the SkyCab project at their 2026 product showcase, the reaction was immediate and overwhelming. This wasn't just another product reveal. This was a moment when an entire industry collectively realized that the rules had changed. The SkyCab was unlike anything anyone had ever seen before. The genius behind the SkyCab lies in its fundamental design philosophy. Unlike traditional electric vertical takeoff and landing aircraft being developed by numerous aviation startups around the world, the SkyCab wasn't designed to be just a flying machine. Tesla engineered it to be a hybrid road and air transportation platform. This meant it could drive on streets like a normal autonomous vehicle when roads were clear or when traffic was light. But when roads became congested or when you needed to get somewhere quickly, the vehicle could simply take to the sky. It could lift off vertically without any runway, achieve flight altitude, and cruise to its destination at speeds that would make ground-based travel seem obsolete. This hybrid approach gave Tesla an enormous advantage over every competitor working on flying vehicles. Most aviation startups had focused exclusively on the flying aspect. They were trying to build electric aircraft that required pilots or remote operators. They were dependent on third-party suppliers for most components. They had no experience with autonomous systems, battery technology, or mass manufacturing. Tesla, on the other hand, had spent more than 15 years perfecting battery technology, autonomous driving systems, and manufacturing processes. The company brought all of this expertise to bear on the SkyCab project. The technical specifications of the SkyCab prototype revealed just how ambitious this project truly was. The vehicle was designed to carry 2 passengers safely and comfortably. The battery pack was engineered to provide a flight range of approximately 250 to 300 kilometers on a single charge. That's roughly 150 to 186 miles. For a flying vehicle, this represented an extraordinary achievement in energy density and efficiency. The battery technology was based on Tesla's latest advanced battery chemistry, featuring improvements in energy density and thermal management that had been developed specifically for the demands of vertical takeoff and landing. Power requirements for vertical takeoff and landing are tremendous. Unlike an airplane that has a runway to build speed, a vehicle that takes off vertically requires enormous amounts of energy concentrated in a very short time period. This is where battery performance becomes absolutely critical. The SkyCab's battery system was designed to deliver peak power during takeoff while maintaining efficiency during sustained flight. The engineering challenges were immense. Too heavy a battery pack, and the vehicle couldn't achieve proper flight performance. Too light a pack, and you wouldn't have enough range. Tesla's engineers spent thousands of hours optimizing every aspect of the battery system to strike the perfect balance. The propulsion system of the SkyCab represented another breakthrough in engineering. Rather than traditional helicopter rotors or airplane propellers, the SkyCab used a distributed electric motor system with multiple lift fans strategically positioned throughout the vehicle's frame. Each motor could be independently controlled by the autonomous flight system, allowing for unprecedented maneuverability and stability. This design meant that if one motor experienced any kind of issue, the remaining motors could compensate automatically, ensuring passenger safety at all times. The redundancy built into the system was extraordinary. Tesla had learned from decades of working with autonomous vehicles that safety systems need to be fail-safe by design, not by hope. The exterior design of the SkyCab was distinctly Tesla. The vehicle maintained the company's signature minimalist aesthetic while incorporating aerodynamic elements necessary for flight. The fuselage was constructed from advanced materials that provided strength while keeping the overall weight as low as possible. Every kilogram mattered when you were fighting against gravity. The doors opened upward in a graceful arc, providing easy access for passengers while maintaining the structural integrity necessary for pressurized flight at altitude. The windows were large and transparent, giving passengers an unobstructed view of the city below during flight. It was a design that managed to be both futuristic and practical, elegant and functional. Inside the SkyCab, the focus was entirely on passenger comfort and safety. The seats were ergonomically designed to provide support during all phases of flight, from vertical takeoff to high-speed cruise to descent. The interior was finished with premium materials that would be familiar to anyone who had ridden in a Tesla vehicle. But this wasn't just a car interior. The cabin pressure was automatically maintained at comfortable levels, similar to a commercial aircraft. The temperature control system kept passengers comfortable, regardless of external conditions. The ambient lighting could be adjusted by passengers to suit their preferences, creating a personalized experience during each journey. Safety systems on the SkyCab were arguably the most advanced ever integrated into any vehicle. Multiple redundant autonomous flight control systems monitored every aspect of the vehicle's operation in real time. If the primary flight computer experienced any malfunction, backup systems would immediately take control. If any sensor showed anomalous readings, the system would automatically divert to the nearest safe landing zone. The parachute systems were present throughout the vehicle structure, capable of deploying automatically if multiple critical systems failed simultaneously. These weren't theoretical safety features. They were systems that had been tested thousands of times in every conceivable scenario, in computer simulations and in real-world testing. The autonomous capabilities of the SkyCab represented the convergence of multiple advanced technologies. The vehicle used Tesla's latest artificial intelligence hardware and software, built on the company's proprietary AI-4 chip. This computer was orders of magnitude more powerful than the autonomous driving computers in Tesla's ground-based vehicles. It needed to be. Flying required processing information in 3 dimensions instead of 2. It required constant monitoring of weather conditions, wind patterns, air pressure, and dozens of other variables that didn't apply to ground vehicles. The AI system had been trained on millions of simulated flight scenarios. It had learned from the successes and failures of thousands of test flights. When the SkyCab took off for the first time, it wasn't relying on artificial intelligence that had just been created. It was relying on a system that had been refined through countless iterations. The sensors on the SkyCab were equally advanced. Multiple LiDAR systems provided 3-dimensional mapping of the environment in all directions. Radar systems could penetrate fog and rain to detect obstacles in other aircraft. Camera systems operated in visible and infrared spectrums, allowing the vehicle to see clearly in any lighting condition. Ultrasonic sensors provided precise altitude and distance measurements. All of this information was processed in real time by the autonomous flight system, which made millions of calculations every second to maintain safe, efficient flight. The redundancy was extraordinary. If any single sensor failed, the system could continue operating safely using the remaining sensors. If multiple sensors failed simultaneously, the system would initiate an emergency landing procedure. But the SkyCab wasn't just a flying machine. That was only part of what made it revolutionary. The vehicle's ability to function as a ground-based autonomous taxi was equally important. This hybrid capability meant that the SkyCab could be deployed in ways that purely aerial vehicles never could be. On a clear day with good traffic conditions, the vehicle might operate entirely on the ground, seeing the established road network to transport passengers to their destinations. The autonomous driving systems were as advanced as Tesla's ground vehicles, capable of navigating complex city streets, interpreting traffic signals, avoiding obstacles, and responding to unexpected situations. The vehicle could wait at charging stations, move itself to pickup locations without passengers, and integrate seamlessly with a broader fleet management system. The real power of the SkyCab came from the flexibility of this hybrid approach. Imagine the journey of a passenger during rush hour in a major city. They call for a vehicle using a mobile app, much like they would call for any rideshare service. The nearest available SkyCab receives the request and drives autonomously to the pickup location. The passenger gets in, enters their destination, and the vehicle's AI system instantly evaluates conditions. The roads are congested with heavy traffic. Estimated travel time by ground would be 45 minutes. The sky is clear, weather conditions are favorable, and there are no other aerial vehicles in the way. The system calculates that flying would take 8 minutes. The passenger agrees, and the vehicle drives to a designated takeoff zone. Once there, the vehicle performs final safety checks, receives clearance from air traffic control, and smoothly transitions to flight mode. The passenger watches the city shrink below them as they ascend to cruising altitude. 8 minutes later, they're descending toward their destination. The vehicle transitions back to ground mode, drives to the exact location where the passenger needs to be, and comes to a stop. The entire journey, including pickup and drop-off, took less than 15 minutes. In a conventional vehicle, it would have taken more than an hour. This scenario wasn't hypothetical. It was the vision that Tesla was actively working to bring to reality. The integration with the broader Tesla ecosystem made the SkyCab even more powerful. The vehicle could communicate with other Tesla vehicles on the road, sharing information about traffic conditions, hazards, and optimal routes. It could interact with infrastructure systems in cities where such systems had been implemented. It could coordinate with other aerial vehicles to ensure safe separation and efficient routing. It could even coordinate with pedestrian and bicycle traffic to minimize conflicts and maximize safety. The entire system was designed to work together with thousands of vehicles operating simultaneously across a city, each one making autonomous decisions that contributed to the safe and efficient movement of everyone in that urban environment. The announcement of the SkyCab project sent shockwaves through the transportation industry. Traditional automakers suddenly realized that they had been thinking too small. They had been focused on incrementally improving existing vehicles, adding more autonomous features, making cars slightly more efficient. But Musk and Tesla were asking bigger questions. What if we didn't need traditional cars at all? And what if the future of transportation wasn't just about making cars drive themselves, but about completely reimagining what a vehicle could be? What if we could solve traffic congestion not by building more roads, but by using three-dimensional space that had been completely ignored for centuries? Aviation authorities around the world scrambled to develop regulatory frameworks for commercial aerial vehicle operations. The Federal Aviation Administration in the United States began working with Tesla and other companies to establish safety standards, traffic control procedures, and licensing requirements for autonomous flying vehicles. Other countries followed suit, recognizing that this technology was coming whether they were ready or not. The regulatory challenges were immense. There were no existing rules for urban air mobility because it had never existed before. Authorities had to balance the desire to promote innovation with the absolute necessity of ensuring public safety. Every aspect of the SkyCab's operation would need to be certified and approved before commercial service could begin. The environmental implications of the SkyCab were profound. The vehicle produced zero direct emissions. It was powered entirely by electricity stored in advanced batteries. The energy efficiency of electric flight was dramatically superior to the efficiency of ground-based transportation in congested cities. A vehicle flying directly from point A to point B used far less energy than a vehicle that had to navigate through traffic, sit in queues, and travel inefficient routes because roads didn't connect every location directly. As cities transitioned to renewable energy sources, the SkyCab would become cleaner and cleaner. The environmental impact of transitioning millions of vehicles from ground-based transportation to aerial transportation would be transformative. The economic implications were equally significant. A vehicle that could deliver passengers to their destination in 1/8 the time wouldn't just save time. It would restructure the entire economy of urban transportation. Ride-sharing services would become cheaper as vehicles became more efficient. People would be willing to travel farther because the journey times would be dramatically shorter. Real estate value in areas that were currently underutilized but well-positioned for aerial transportation hubs could skyrocket. Businesses could relocate away from congested downtown areas and still provide their workers with fast commutes. The distribution of economic activity across cities could change fundamentally. The SkyCab wasn't being developed in isolation. It was part of a much larger vision that Elon Musk had articulated. At Tesla's 2026 showcase, the company revealed how the SkyCab fit into an integrated ecosystem of advanced technologies. The vehicle would be powered by Tesla's advanced battery technology and autonomous AI systems. It would communicate with other Tesla vehicles and infrastructure systems. It would potentially be serviced by Tesla's network of service centers. Tesla. Optimus humanoid robots might eventually perform maintenance and cleaning. The entire system was designed to work together, creating a unified platform for future mobility. The SkyCab represented more than just transportation innovation. It represented a fundamental shift in how humanity was approaching the problem of moving people and goods through urban environments. For more than 100 years, civilization had been constrained by the limitations of ground-based transportation. Cities had sprawled outward because that was the only way to accommodate population growth. Traffic congestion had become a defining feature of urban life. Billions of hours were wasted every year in traffic jams. The SkyCab offered a way to transcend these constraints. It offered a path to cities that were less congested, more efficient, and more livable. The first prototype of the SkyCab had completed thousands of test flights. These weren't simple tests. They were comprehensive evaluations of every system, every subsystem, and every possible failure scenario. The vehicle had been tested in various weather conditions, from clear skies to rain to wind. It had been tested at various altitudes and speeds. Its autonomous systems had been tested against thousands of simulated emergency scenarios. The data from these tests had been fed back into the design, leading to continuous improvements and refinements. By the time the prototype was revealed to the public, it had proven itself to be one of the most reliable and capable vehicles ever built. The timeline for commercial deployment was aggressive but realistic. Tesla planned to have a limited number of SkyCabs operating in select cities by 2027. Initial service would be in carefully controlled environments with full safety monitoring. As the company and regulators gained confidence in the technology, the deployment would expand. By the early 2030s, SkyCabs could be operating in major cities around the world. By the middle of the decade, the vehicles could begin to fundamentally reshape urban transportation. By 2040, it was plausible that a significant portion of urban transportation would be aerial. The ground-based road network would still exist, but it would be supplemented by a three-dimensional transportation system that used airspace that had been essentially empty throughout human history. The challenges ahead were substantial. Regulatory approval would take years. Infrastructure would need to be developed to support aerial operations. Charging stations would need to be built at strategic locations throughout cities. Air traffic control systems would need to be upgraded to handle thousands of autonomous aerial vehicles operating simultaneously. Safety standards would need to be developed and rigorously enforced. Public perception and acceptance would need to be cultivated. The technical challenges had been largely solved through years of development. The remaining challenges were primarily regulatory, infrastructural, and social. The financial implications were staggering. If even a fraction of ground-based transportation was eventually replaced by aerial transportation, the market opportunity would be enormous. Tesla was positioned at the forefront of this revolution. The company had the expertise in battery technology, autonomous systems, and manufacturing that were essential to success. The company had the financial resources to weather the long development period. The company had the cultural credibility to convince people that this vision was achievable. Competitors were watching closely. Traditional automakers were beginning to invest in aerial vehicle projects. Aviation companies were exploring autonomous flight systems. But Tesla had a head start that might prove to be insurmountable. The geopolitical implications were also significant. Countries that adopted aerial transportation early would gain substantial advantages in terms of transportation efficiency, urban livability, and economic competitiveness. Nations that fell behind would face increasing challenges in attracting talent and investment. The development of the SkyCab was not just a business competition. It was a race for technological leadership that would shape the global economy for decades to come. Governments were paying close attention. Some were creating regulatory frameworks to encourage development. Others were establishing research programs to ensure that their countries maintained technological parity. The stakes were as high as they had been in previous technological races like the space race or the race for semiconductor dominance. The social implications were perhaps the most profound. For the first time in history, technology was offering a genuine solution to urban congestion. Millions of people who currently spend hours every day stuck in traffic could potentially reclaim those hours for more productive or meaningful activities. The quality of life in cities could improve dramatically. The stress and frustration of commuting could be eliminated. The air pollution from vehicles could be reduced substantially. The noise pollution from traffic could be diminished. The psychological impact of these changes would be enormous. People would have more time with their families, more time for work, more time for leisure. The simple fact of being able to travel across a city in minutes instead of hours would fundamentally change how people experienced urban life. The environmental movement embraced the SkyCab with cautious optimism. Here was a technology that could dramatically reduce transportation-related emissions while improving quality of life. Yes, electricity would need to be generated to power the vehicles, but that was a problem that was increasingly being solved through renewable energy expansion. The energy required to move a person through the sky was substantially less than the energy required to move a person through congested traffic on the ground. The SkyCab aligned perfectly with climate goals and environmental sustainability objectives. Environmentalists who had often been skeptical of technological solutions were finding reasons to believe that this technology could actually make a difference. Cities could become denser and more walkable at ground level, while traffic was handled in 3 dimensions above. The entire character of cities could change. Urban environments could become more livable, more beautiful, and more sustainable. The design principles that had shaped cities for the past century could be abandoned in favor of new paradigms that took advantage of aerial transportation. The pessimism that had characterized much of the discourse around climate change and urban quality of life could begin to lift. Here was proof that innovation and technology could solve hard problems. Here was evidence that the future could be better than the present. The SkyCab was more than just a vehicle. It was a symbol of humanity's capacity to imagine better futures and build them. The development of the SkyCab also represented a convergence of multiple technological trends that had been developing independently for years. Advances in battery technology had made electric propulsion practical. Advances in artificial intelligence had made autonomous flight possible. Advances in materials science had made lightweight construction feasible. Advances in electronics and manufacturing had made integration of complex systems affordable. The SkyCab was only possible because all of these technological threads had reached sufficient maturity simultaneously. Elon Musk and Tesla had simply had the vision to see how these threads could be woven together into something revolutionary. They lacked the battery expertise that Tesla possessed. They lacked the autonomous driving experience. They lacked the manufacturing scale. They lacked the vision of a completely integrated system. Tesla was competing not just on the technology itself, but on the entire ecosystem that supported that technology. That gave Tesla an advantage that might be decisive. The first commercial routes for SkyCab service would likely be premium pricing initially. Early adopters would be wealthy individuals and business travelers who valued time above price. But the business model was structured to bring costs down over time. As production scaled up, manufacturing costs would decrease. As more vehicles were deployed, infrastructure costs would be amortized across more rides. As demand increased, utilization rates would improve. The personal experiences of passengers during the early SkyCab flights were transformative. Flying through the sky in a sleek, autonomous vehicle, watching the city below transform into a pattern of roads and buildings and parks, experiencing the freedom of three-dimensional movement created a sense of wonder and possibility. People reported feeling genuinely moved by the experience. The psychology of flight had always had a powerful appeal to humans. Flying had always symbolized freedom and transcendence. The SkyCab brought that experience to the everyday transportation network. It made flying accessible to ordinary people for ordinary journeys. That was revolutionary. The SkyCab represented the culmination of decades of technological progress. It stood on the shoulders of countless innovations in battery technology, autonomous systems, material science, and manufacturing. But it was more than just an accumulation of existing technologies. It was a new synthesis, a new possibility, a new vision of what transportation could be. Elon Musk's greatest achievement was not the SkyCab itself. It was the ability to see that synthesis before anyone else, and the capability to marshal the resources and talent necessary to bring it into reality. As 2026 progressed, the SkyCab project accelerated exponentially. More prototypes were built, each one incorporating improvements learned from previous iterations. Testing became increasingly rigorous and comprehensive. Partnerships were established with major cities around the world that were interested in becoming early adopters of aerial transportation. Regulatory discussions advanced rapidly as governments recognized the transformative potential of this technology. Infrastructure planning began in earnest, with detailed studies conducted on optimal locations for takeoff zones, charging stations, and maintenance facilities. The vision that had seemed impossible just years before was becoming increasingly concrete and achievable. Real investments were being made. Real infrastructure was being built. Real timelines were being established for commercial deployment. The automotive industry was fundamentally being disrupted. Companies that had dominated ground transportation for a century were suddenly facing the possibility of becoming irrelevant. Traditional automakers scrambled to develop their own aerial vehicles or establish partnerships with companies like Tesla that had the expertise to compete. The transportation industry was being revolutionized, not just the technology of transportation, but the entire business model, the infrastructure, the regulations, and the fundamental understanding of what was possible. And the future of human mobility was being reimagined. The SkyCab wasn't just a vehicle. It was the herald of a new era in transportation. It was proof that the future could be radically better than the present. It demonstrated that innovation could solve problems that had seemed intractable for generations.